our next example kind of continues along the same theme. And here, let's take a look at it. Here we're given that the terminal voltage of the battery is 18 volts, 18.00 volts when a current I flows around the circuit below. So this could be a real battery. There would be internal resistance, but what we have here, we have a steady current flowing, and we're given the potential difference between the two terminals of the battery while there's a current flowing is 18 volts. And so it current flows from the high potential side all the way around to the low potential side and through the battery. So it's a steady current I all the way through every element in the loop. Once I know the direction of current flow, current always flows from high to low potential. So in our case, the plus, I can write since it flows in this direction, this is the high side of this resistor, this is the low side. Flows, same current flows here, high side to low side, and through here, same current I flows from high to low. So I can mark the polarity of each instrument, or of each element, I should say. The long bar, remember, is always the positive terminal and the high potential terminal, and the short bar is always the negative. So we've got this picture. And then we're asked to find A, the current, B, the potential drop across each resistor, the power dissipated in each resistor, and the power supplied by the battery. I'll do this one in some detail. As I go from A around to B, then I know the total potential difference from A to B is a drop, right? If I go from A to B in this direction, or if I go around here in this direction, I'm going from high to low. And so the final minus the initial, that's 18 volts, and so it's a minus 18 volts as I go from A to B, high side to low side. So I drop by 18 volts. As I go across each resistor, I know that V is equal to IR. So, and then I have to pick out which sign to associate with it. I usually just write plus or minus on each one. So plus or minus IR3, plus or minus IR2, plus or minus IR1. And then I go and select the last sign here. As I move across this one, the minus sign, go across this one, the direction current, minus sign, go across this one, minus sign. Well, that gives me an equation, plug in all the values, and gives me an equation that only has one variable in it, namely I. I can lump all of those together. Current I is minus 18 over minus 9, and the result is 2 amperes. So the current that's flowing around the circuit is 2 amperes. Part B, the voltage drop across each resistor. Well, again, that's the voltage drop. So delta V1 and the voltage drop is minus IR1. 2 amps, 4 ohms, minus 8 volts. Similarly for delta V2. It's the current going through it times the resistor, and it's a drop. And likewise over here, resistor R3 is 4 ohms, and there's 2 amperes flowing through it, so minus 8 volts. So negative, all are negative. Part C, let's calculate the power dissipated in each resistor. And I'll use the full formula. The power is minus I times delta V. So the power dissipated in resistor 1 is the current flowing through it times the voltage drop across it, which we calculated in part B. So we get a minus is a plus, or plus 16 watts. Similarly for 2, resistor 2 has a 2 volt potential drop, that's the delta V, and I is 2, and minus gives me 4, and then 3 again is another 8 minus 8 volts is this potential drop across it times the current, and again 16. If you look at this, the total power dissipated in all the resistors is just the sum of all of these. So you get 16 plus 4 is 20, plus 16 is a 36 watts total. What about the battery? The third, or the part D was find the power supplied by the battery. Again, we can use the same general formula. In our case, the current is flowing through the battery from minus through the positive. If you take a look up here, current is going around in this direction, so it goes from minus to positive. That's what I've drawn here. Delta V. In this case, as I go from the short bar to the front, that's going from low to high, so it increases by 18 volts. Current throughout the whole circuit is I, so I is 2 amps. Delta V is 18 volts, and I still have this minus sign, and so the battery is losing 36 watts of power. It's giving up that amount of power, energy per time, to the rest of the circuit. So here the negative sign indicates that the battery is discharging. It's losing energy per time by this amount, minus 36 watts. Note that if we add those two, the power dissipated in the battery, lost by the battery, plus the power that's gained by the resistors, I get minus 36 plus 36 watts, which is 0. And power is energy per time. So energy in the battery, energy in the resistor. And so essentially this is a conservation of energy, that the energy per time supplied by the battery is gained by all the resistors. So the net energy loss is 0. It's just that one thing is losing it and the other thing is gaining it.